All right. Hello, guys. Welcome to the post-contest discussion of today's Codeforces Contest Div 2. Today is the first contest after the launch of the new model. So there were some rules that were set in place, but discuss about that later. So let's start with the first problem of today. That is simple palindrome. All right. What does the problem say, guys? We are given a string of length n consisting of lowercase. We need to find a string of length n of lowercase English vowels only, that is A, E, I, O, U, which minimizes the amount of palindrome subsequences in it. All right. So, guys, what does the problem say? The problem says that we are given, we need to make a string of size n. All right. And this n, string of size n, should only consist of A, E, I, O, and U. All right. Now, whatever string we do generate, we want to minimize, all right, number of palindromic subsequences in it. Okay, guys, this is what the problem statement says. So the solution is very direct, but let's try to build the intuition and the proof of why what we are thinking is a is the solution. So guys, what does a palindromic subsequence mean? Let's see that if I have A, I, A, B, and C, all right, or let's say this is A and this is B. Do you see that BIB is a palindromic subsequence and AIA is a palindromic subsequence? Similarly, A and A is a palindromic subsequence and B is a palindromic subsequence. Not to mention that A, B, I, B, A all by itself are palindromic subsequences by itself. Yes or no, guys? Yes, is this much clear what palindromic subsequences are? Now, if this much is clear, we want to minimize this, all right? The first thing that we can see is that if I have two characters of the same kind, and if I have some characters between them, do you see that the number of palindromic subsequences I can create increases? Why does it increase? Because if you look at these two letters, all right, if they were next to each other, the only palindromic subsequence would have been these two characters by itself and then connecting these two. But now, since there is something between it, I can have these two, I can have these two, and apart from this, I can also select any letter as the middle element and I can make a palindromic subsequence. Yes or no, guys? Do you see that if I place different characters between two characters of the same kind, it forms more palindromic subsequences. Is this observation clear? Let's say we have A and then we had I and A. This is worse and this right here is better. All right. What do we mean by this? We mean by this is if we have a string, it's always better to have characters of the same kind together. Yes or no, guys? Yes?
Yes.
All right. Now, if this much is clear, the first thing we have already proven, we want characters of the same kind together. Characters of the same kind all right. Now the next thing that we want to see, let's say we have n is equal to 5. All right. Here, if I used only one character to make up the entire string, the number of palindromic subsequences is equal to the number of subsequences of this entire A. So do you see that the number of palindromic subsequences here is 2 raised to 5 minus 1? Yes or no, guys? For an array of length n, there are 2 raised to 5 subsequences and 1 is empty. So the number of total palindromic subsequences here is 2 raised to 5 minus 1 because everything is palindromic. But instead of this, if we use, let's say, 2 characters, all right. Let's say I used E here and E here. So you can see that the number of subsequences this became 2 raised to 3 minus 1 and this became 2 raised to 2 minus 1. All right. We know for a fact that the addition of this is smaller than 2 raised to 5 minus 1. Is this much clear, guys? Clear? Okay. Now if this much, Harsh Thakur says, why 2 raised to 5 minus 1? Harsh, because if we used all characters as the same, do you see, like if everything was A, do you see that the number of subsequences that we could create would be 2 raised to 5 minus 1? Like for each index, I would have a choice to take it or not take it. Yes or no, Harsh? Yes. So that is why the number of subsequences of using only A's would be 2 raised to 5 minus 1. But now you can see that if we split this, the answer decreases. So can we say that using more vowels with less frequency is more optimal? As I said, guys, instead of using one character, using 2 characters is more optimal. Similarly, can I say instead of using 2 characters, using 3 characters is more optimal? And instead of using 3 characters, 4 is more optimal, and so on and so forth. For this, which is A, B, C, for this, which is of length 5, can I just say that A, E, I, O, U? This is the most optimal because the number of palindromic subsequences is 2 raised to 1 minus 1, 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 2 raised to 1 minus 1. Because these are the sizes for each particular character. So the number of palindromic subsequences here is only 5. This is 2 minus 1, 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 which is just 5. Okay. So is this much clear for everyone, guys? First of all, we want to have all characters of the same kind together, and using more vowels with less frequency is always optimal. So since we have proved this, let's say we are given n, all right? N is equal to 7. We want to distribute this among these 5 vowels as equally as possible. So do you see, I can have 1A, 1E, 1I, 1O, and 1U. I have used 5 characters up till now. Now, I need to use 2 more characters. Guys, no matter, now do you agree, instead of putting these 2 in one character, I would like to put these 2 in 2 different characters, possibly A and E or I or something like that. Yes or no, guys? I would like them to be in different characters. So now if this is the case, I would put an A here and I would put an E here. All right. In this case, guys, you can notice that the number of subsequences here is just 2 raised to 1 minus 1, 2 raised to 1 minus 1, 2 raised to 1 minus 1, 2 raised to 2 minus 1, and 2 raised to 2 minus 1. All right. And it can be easily seen that this is the most optimal condition. So what is the solution, guys? If I have n length as my string, for every A, E, I, O, U, okay, I am going to have n by 5 characters of it. N by 5 characters of A, n by 5 characters of E, n by 5 characters of I, n by 5 characters of O, and n by 5 characters of U. After this, some amount would be remaining. Do you guys agree this amount would be smaller than 5? Because if it was by 5, if it was greater than equal to 5, in that case, we would just have one more frequency of A, E, I, O, U. Yes? All right. Now, if this is the case, let's say it is 4. If this is 4, I will just add 1 in A, 1 in E, 1 in I, 1 in O, right? I have added 4. If it was 3, right? If n modulo 5 was 3, then in that case, I would have added in A, E, and I. If it was 2, I would have only added in A and E. And if it was 1, I would have only added in A. If it was 0, I wouldn't have added in any of them, and I would have printed the string as it is. Is this much clear, guys? Any doubts, anything as such for people who weren't able to solve? Is it clear? The idea is that I want to have as even distribution of frequencies as possible. That is why I'm going to have n by 5 frequency of each character, and after that I will have a remaining number left. That number I will just distribute among the characters evenly. So how do we go about solving this? Very simple, guys. Let me just show you the solution. So I think this is not necessary, but yeah. I have my string S, which is A, E, I, O, U. I iterate from I is equal to 0 to I is equal to 5. I want to print those characters. I will print n by 5 occurrences of that character, and after that, if n by 5, n modulo 5 is greater than I, it means that if n modulo 5 was 1, then I would want to have an extra 1. If it was 2, then I would want to have A and E. If it was 3, I would want to have A, E, I. If it was 4, I would want to have A, E, I, O. So that is why if n modulo 5 is greater than I would have an extra occurrence of that character. Otherwise, I would not. So I am just having the count of how many occurrences I want of that character, and then I am passing the character itself. If you use the function string and you pass an integer and an character, it makes a string of that many occurrences of that character. That is exactly what I'm printing. This is a O of n solution. Is this much clear, guys? Great. Is this clear for everyone? For people who weren't able to solve as well? All right. I didn't understood the test case. Why for 2 output can't be IA or something else?
सर
It yes.
सर फिर से समझाओ ना, क्या समझाया, नहीं समझ आया।
Okay. It can be IA. Wait. It can be IA. I think this is just given wrong. Okay. So I'll just explain it again for people who weren't able to understand. So who was the person who asked the doubt? Could you just unmute?
यस सर।
Okay. So is this much clear? Like I would want to have the characters together. Let's say I gave you a string. I want to reduce the number of palindromic subsequences. In that case, I would just group all the characters which are the same together. Is this much clear?
Yes, sir.
Okay. Now, if this much is clear, I am showing you, right? If I made all characters the same, that is everything I made A, how many palindromic subsequences are there? Do you agree that no matter what subsequence I pick up, it would be palindromic?
Yes, sir.
Like if everything is A, no matter what subset I pick up, it will always be palindromic. So can I say the number of palindromic subsequences is 2 raised to n minus 1, or in this case 2 raised to 5 minus 1? Yes.
Yes.
Now, instead of having everything as A's, let me have half of them as E's. Do you see then the answer become 2 raised to 3 minus 1 plus 2 raised to 2 minus 1. And can you notice this answer right here is smaller than 2 raised to 5 minus 1?
Yes.
Okay. So can you notice by increasing the number of characters, like if I have more unique characters, my answer decreases? Like if I
Yes.
also included an I, or my answer would decrease further. So the most optimal is if I have all my characters, my answer is the smallest possible, correct?
Yes, sir.
Okay. So now my goal is very simple. For a given n, let's say n is 12, all right? If n
Mm.
is 12, I just want to distribute this 12 among A, E, I, O, U as efficiently as possible. Basically, I want their frequencies as close as possible. So for A, let's say I had two frequencies. This I had two, this I had two, this I had two, and this I had two. How many characters did I use up? 10,
10.
right? How
Mm.
many am I left with?
2.
Okay. So I can just put one here and I can put one here because I want them to be in different characters. Now this number right here, what is this? This is n divided by 5. 12 divided by 5 is 2. So that is why
Mm.
each character will get at least a frequency of 2. And after that, I have a remainder left. Now, depending upon what the remainder is, if the remainder was 1, then I would have only A. If the remainder is 2, I would have A and E. If the remainder is 3, I would have AEI. If the remainder is 4, I would have AEIO. And if the remainder is 5, I would have AEIOU. Okay.
Mm.
So that is all. So in n is equal to 5, I print A 3 times, E 3 times, I 2 times, O 2 times, and U 2 times. This is the most optimal string. Okay.
तो सर बगल बगल में ही होने चाहिए, मतलब 3 ए एक साथ, 3 ई एक साथ.
Yes, because that will reduce our answer, yes or no? Here, you saw
Yes.
that instead of, so that is why we can say that having them together is always better. All right.
Okay.
Great. Now, if this much is clear, guys, let's move on to the next problem. All right, which
Mm.
is problem B2. Right. Now, guys, B1 and B2 have the same problem, have the same solution. Let's have a look at that. Okay. The strict teacher, Narek and Soak, were busy preparing this round, so they have not managed to do their homework and decided to steal David's homework. Their teacher, Strict, noticed that David has no homework and wants to punish him. She hires other, so this is basically useless, right? Now, the classroom can be represented as an one-dimensional line with cells from 1 to n. At the start, all M teachers and David are in distinct cell. They can make moves. During each move, David goes to an adjacent cell or stays to the current one. Then, each of the M teachers simultaneously move somewhere. Okay. Now, what is given in the question, guys, that we are given David's position. We know the number of queries. All right. The number of queries here is 1. We are given David's position. We want to find, and this is the teacher's array. These are the teacher's position. For every David's position, I want to know what is the most optimal answer. All right. Like what is the maximum number of moves before any teacher catches David? Is this much clear, guys? Okay. So let's discuss the problem. What does the problem say, guys? You are given a 1 to n number line. Okay, it starts at 1 and it ends at n. Between this, all right, here it is, let's say 1, 2, 3, 4, 5, 6, 7, 8. Now you are also given some teachers. Let's say one teacher is at 2, one teacher is at 4, one teacher is at 7. Okay. After this, we need to process Q queries. And each query gives me the position of David. It is for sure that it is not a position of a teacher. All right. Since it is not, let's say it's not a position of a teacher. Let's say David comes over here. All right. David is over here. Do you agree? No matter what David does, all right, David will be caught in one move. Yes or no, guys? Because if David goes here or here, David will be caught. So David stays. And after this, one of these teachers will come here and David will be caught. Yes? Correct? Now, similarly, let's say David, let's remove this from here and let's put this over here. Now, consider David is over here. If David is over here, David would like to stay here because if he goes here, he goes closer to one of the teachers. And if he goes here, he goes closer to one of the teachers. So let's say he stays here. He does nothing. This teacher will move here. This teacher will move here. Right? And after this, let's say he does nothing again. This teacher will move here and he will get caught. So when David is over here, do you see the answer is 2? If this is my particular sequence, okay. If this much is clear, guys, is this much clear? Like, is the problem clear? Like for every query, we need to print the maximum number of moves before he gets caught. Yes? Is the problem clear, guys? Do put a yes in the chat if it is indeed clear. All right. Great. Now, if this much is clear, guys, I have one statement to make. What statement is that? Do you guys see that no matter where David is, David will only get caught either by the teacher directly towards the left or a teacher directly towards the right. Let's say David was here. David can only get caught by this teacher or this teacher. Yes or no? Tell me, guys. Yes, because this is the teacher closest from the left. This is the teacher closest from the right. So this teacher would be able to close down on David the fastest. Yes, like this teacher would take more time. This teacher would take less time. So this is the first observation. What is the first observation, guys? Only closest from left and right matter. All right. This is the first observation, guys. If this much is clear, now there are some cases. What are the cases? Let's say, let's take 3 cases. All right. In the first case, David is over here. All right. And there is no teacher on the left. This is basically 1. There is no teacher on the left and there is one teacher at position X. Okay. The second case is David is over here. There is no teacher on the right hand side. So the teacher, there is no teacher on the right hand side. So this is basically n, and there is a teacher here. And the third case, which is the general case, that is basically there is a teacher here and there is a teacher here. Do you agree, guys? If we find the solution for all three cases and we are somehow able to find the closest to left and closest to right teacher, then we can more or less answer each query very fast. Correct? Okay. If this much is clear, let's solve this. So guys, let's consider the first case where there is no teacher towards the left. Okay. So the array looks something like this. David is over here and let's say the teacher is here at position X. Okay. Guys, do you see that David would want to go over here at position 1 and this teacher would more or less follow? Yes or no? Correct? So, do you agree the amount of time required for this teacher to catch up to this person is more or less the same as the time required for this teacher to reach position 1? Yes or no, guys? Tell me. Yes. Is this much clear, guys? All right. If this much is clear, how much time does it take for a teacher at position X to reach position 1? If the sound is breaking, do let me know. I will change my microphone. All right. Is the sound breaking?
Yes, sir.
Yes. Oh, you guys should let me know first. Let me get that changed right away. All right. Give me 1 second. Let me get that changed. Great. I hope I am audible now and my audio is not breaking. All right. Yes, guys. Great. Okay. If my audio is breaking, do let me know before time. So now there would be no issues. So, guys, if the teacher is over here and David is over here, do you all agree that David would want to go to position 1? Yes or no? Yes. Now, if David would want to go to position 1, do you agree that the teacher would want to follow David? So can I say that the time required for the teacher to catch David is basically the time required for the teacher to reach position 1? Yes or no, guys? Yes. So this is basically just x minus 1 time, because David would try to reach position 1, and then since David is already towards the left hand side, it wouldn't take much time. After this, the teacher would follow one at a time and eventually reach position 1. Is this case clear, guys? Great. Now, guys, the second case. What is the second case? Let's say, all right, the teacher is on the left hand side and David is over here. There is no teacher towards the right hand side. Do you agree that David would try to go towards the right and the teacher would want to follow? Yes. So do you agree that the David would reach N? All right, this is David. And then the teacher would reach N as well. So in the second case, where there is nothing towards the right, the answer is just N minus X if the teacher's position is X. Is this clear as well? Great. If this much is clear as well, guys, let's move on to the third case. All right. Let's say we are at position X. All right. And this is position Y. Okay. And David is somewhere in between. Okay. Let's say David is over here. Right. Now you can see that David is closer to this teacher. All right. So do you agree that David would try to get the farthest from the closest teacher? What do I mean to say by this? Let's say this position is 1 and this the distance from the first teacher is 1, the distance from the second teacher is 4. Do you agree I would like to increase this? Yes. So if I would want to increase this, what do I basically do? I go towards the right. Now this becomes 2 and this becomes 3 and David comes here. All right. After this teacher would come here and this teacher would come here. Basically, the distance would again become 1 and this distance would become 2. Now, no matter what I do, if I go here or if I stay here, in the next move, the teacher would catch me no matter what. Yes or no, guys? Yes. So, do you see that if we calculate, just let me show you all right. If this is position X, this position Y, and David is over here. Okay. Now, let's say distance of David from here is 1. Distance of David from here is 4. All right. Now, do you agree the distance between them is 3? Yes or no, guys? Like the difference between their distances is 3. Okay. Do you also notice that after each operation, the distance reduces by 1? Yes or no? Yes. All right. Now, how many operations would I like to do before this gap closes in? There is a very simple formula to this as well, but let me explain what I came up with, right? So guys, the thing to notice is that from here, the distance closes in by 1, and from here, the distance closes in by 1. All right. What is the amount of time required? Like how many steps would I go towards the right? This can be simply said to be 4 minus 1, which is 3, divided by 2, which is 1. All right. How did I come up with this formula? Let's have a look. Let's say this is position X, this is David's position, and this is position Y. All right. X, D, and Y. Now, this distance can be said to be D minus X, and this distance can be said to be Y minus D. All right. Now, no matter where I go, all right, the difference between them is what do I say? Absolute of Y minus D minus D minus X. So, right, Y minus D minus D minus X. All right. So, guys, do you agree if there were no moves in between. All right, this distance is, let's say, 4. This distance is, let's say, 2. I would like to go one step this way. So this distance becomes 3 and this distance becomes 3 as well. Correct? Yes or no, guys? Tell me. Yes. Now, how many moves did I perform? If this is 4 and this is 2, the difference is 4 minus 2, which is 2. All right. Do you agree? No matter what step I do, one becomes +1 and the other one becomes -1. Let's say I went in this direction. Or if I went in this direction, this became 4 minus 1 and this became 2 plus 1. Yes or no? Yes. So both points would either one point would get closer by 1 point and 1 point would increase by 1 point. Yes or no? So now can you see that if the difference between this and this is, let's say, Z, the number of operations I would do is Z by 2. Yes or no, guys? Because I would like to add Z by 2 to one of them and I would like to decrease Z by 2 to one of them. Correct? Tell me, guys. Yes or no? Yes. Now, if this much is clear, all right. If the difference between them is difference, all right, I am performing difference by 2 moves. Okay. Keep this in mind. After this, do you agree, guys? If in the start, this distance is 1 and this distance is 4, all right. If I move over here, after this teacher would also come here and this teacher would also come here. Do you agree the minimum time required for a teacher to reach David is still the same? Like if this is here, the teacher comes here and teacher comes here. Still, if it was teacher's move, in one move, the teacher would catch David. Yes or no? Because let's take one more example. Let's say we had 10, we had 9, and we had 7. Okay, I would like to go in this direction. So David would come at 6, teacher would come at 8, and teacher would this is not 7, consider this is not 10, this is 1, and this would come at 2. Do you agree still the minimum number of time required for a teacher to reach David is still 2? Yes or no, guys? Earlier it was 2, now it is still 2 after performing this move. So after performing all the possible moves, do you agree that the time required to catch David is still minimum of distance left, comma distance right? Yes or no, guys? Earlier I calculated distance left and distance right. Since this still remains constant, I would be adding that to my answer. Exactly. So is this much clear, guys? I am trying to minimize I'm trying to maximize the minimum difference. So that would take me difference by 2 moves. And after that, the time required to catch David is just David standing as it is where he is. And then just the police coming him to catch him. All right. Is this much clear? Do let me know if you have doubts. If this much is clear, guys, that is more or less the solution. Now, the only thing we need to consider is how do we find the teacher towards the left and teacher towards the right? This is very simple. If you store all the teachers in a particular vector and sort them, all right, we can binary search on the teacher that is closest towards the left and binary search towards the teacher that is closest towards the right. Now, there is a very simple way in C++ to do this. If your position is X, if you call the upper bound function on X, you will find this particular index. And if you do upper bound -1, if you got that index and you go to the previous index, since police is cannot be on X, the next index or the previous index that it points to would be its leftmost. Is this much clear, guys? Like if I find the leftmost, its next element is the closest from the right. And if I find the rightmost, its previous element, let's say if this is index I, this would be index I minus 1. All right. This can be easily done using binary search as well. But you can also do this using the lower bound function in big O of log n per query. So let me just share the implementation with you guys. Now, this is very simple, guys. Just ignore this. You can just, you can see that this X and this X cancels out, but I'll share the solution. So I take in all the teachers, I sort them. After that, I say that my right index is just, now since nothing is the same, I can use upper bound or lower bound. I'm using lower bound minus ARR dot begin. After that, I'm just saying the index of the left element is right minus 1. Now, if right is equal to m, meaning that there is no teacher towards the right because the indices are from 0 to n minus 1, m minus 1, right? I am just printing n minus ARR of left. This minus x and plus x gets cancelled, so ignore that. Similarly, if left is equal to -1, it means that there is no police or no teacher towards the left. So in that case, I would just be printing ARR right -1. This x and this x gets cancelled, so ignore that as well. Now, the next case that we discussed, I know my distance from the left, I know my distance from the right. I would be making absolute of distance L minus distance R by 2 moves. And after doing these many moves, how many moves would it take for the teacher or police to catch me? It would be minimum of distance L, comma, distance R. That is all. You can see it's a very straightforward and clean solution. It's a big O of n log n plus q log n solution. Is this much clear, guys? Great. If this much is clear, let's move on to problem C. Problem C is an interesting problem. I think it would bring up a very clean solution. So what does the problem say? Let me just share with you. All right. You are given a series of strings, right? We are given n strings. All right. And each string is of size m. Our task is to select a subset of these strings and concatenate them in order. All right. If you look at the particular problem, let's take this. Let me just write it down. It's N R R A R E K N K R E K Z. All right. So this was gotten by concatenating the first and the last string. Okay. If you choose first and last, you have to concatenate first the first one and then the last one. All right. So here is the string that you form. Now on this string, what operation does Narek do? He first finds n, then he finds an a, then he finds an e, then he finds a k. As soon as he finds the first Narek, he finds r and then e and then k. He adds 5 to his score. After that, he again finds n, a, r, e, k. So in this case, he adds 10 to his score. Do you see, like after he has chosen them, these elements would be taken or removed. All right. So these elements are gone. Now, from the string that is left, all those characters which were not taken, this RR, this K, right, from NAREK, that many points will be deducted. So you can see that I gained 10 points and 3 points were deducted. That is why my answer here is 7. Okay. We want to find the maximum possible answer. Yes or no, guys? Tell me. Yes. Now, the thing to notice is that let's say the string was NAREK and NARE. Okay. I would have taken NAREK. I would have taken NARE. All right. Because I was not able to reach K. Do you agree that my answer would be 5 minus 4, which is 1? Yes or no? Now, guys, the thing to notice is that this can also be seen in this way. Consider all the characters you have taken till now. All right. This is nothing but 9. All right. Now, do you agree that now I want to find index 5 or index 4 basically? If you look in zero-based indexing, NAREK, I want to find index 4 of the string in the next part of the string, correct? Because this index is not 0. For example, if I would have found K, I would have gone back to index 0. All right. But since this index is not 0, do you agree that if I am at index I, let's say I'm at index 4, there are 4 characters that I have taken which need to be returned or which need to be subtracted? Yes. Now, do you see that this 4 was counted here? So first we would need to subtract 4 from this, and then we would also need to subtract 4 because that is how much the GPT reduces. So first reducing it from our answer and then adding it to GPT's answer and reducing it. So another way to look at it is like this. If you know the number of characters you have selected, and after that you subtract 2 times the index you are on in the end, it becomes 1. Yes. Let me explain this again, just for people who haven't understood. This is the string which we would be iterating on. All right. This is what we want, right? First we want N, then A, then R, then E, then K. So this is index 0, 1, 2, 3, and 4. Let's say the string is NAREK and NAREK. I chose this entirely, and then I chose this, chose this, chose this, chose this. Let's say this is not there. Do you agree the next character which we want is K? Yes or no? Correct? TB, tell me. Yes. Now, do you agree the index corresponding to K is 4? Can I say that since this is index 4, there are 4 characters before it which have been taken? Yes? Okay. So, the number of indices I have chosen is 9. All right. Now, how many characters I would not count? It would be 4, right? So, Alice's score would be 9 minus 4. Now, do you agree that let's say there were R, and so on and so forth? These would be counted. This would be 2. But then this 4 would also be added to GPT's score because this we didn't take. So we will add 4 here. And then our score for this string, which is NAREK, NARE, would be 5 minus 6, which is minus 1. Correct? Yes. So if I already know these characters and I know these characters, okay, this is GPT score already, and this is my score. If I've already calculated, if this is Y, this is X, I've already calculated X minus Y. Okay. Now, if I know which index I am on, index I in the end, do you agree by doing minus 2 times I, it basically works? because this right here is 9 minus 4 minus 2 minus 4, which is basically 9 minus 2 minus 2 times 4. 9 is the number of characters we took up. 2 is the number of characters which were by default in GPT score. And 2 times score is reducing this from R score and adding it to GPT score. Is this much clear, guys? All right. If this much is clear, this will now help us build our dynamic programming solution. Okay. How do we apply dynamic programming on it? We are given some particular strings. All right. Do you agree that this is index 0, index 1, index 2, index 3, index 4? I want to know, like, if I'm on index 0, I have a choice either to pick this string or to not pick this string. Then I can go to index 1, pick it or not pick it. And after choosing a particular subset, I want to calculate the answer. Yes or no? Tell me, guys. Yes. Now, how do I go about calculating this? Let me show you all. Let dp of I, comma j represent that I am on the ith string. All right. And I want to start taking up from the jth character. What is this j, guys? This j is a number between 0 to 4 which represents NAREK. All right. This index 0, this index 1, this index 2, this index 3, this index 4. So if I am on, let's say dp of 1, comma 2, it means that on the first string, I either have a choice either to take this string up or to not. But let's say if I do, I need to start taking R first, then E first, then K first, and so on and so forth. Yes or no, guys? Is this much clear? All right. If this much is clear, let me define what my DP state says. DP of I, comma j represents that I am on the ith index, jth character, and it is the max possible answer from indices I to n minus 1. Basically, I have all my choices from string I plus 1 up till n minus 1. DP I, comma j stores the maximum possible answer, okay, over all choices. Now, the only thing we need to figure out is how would we calculate the answer. If I am at DP I, comma j, I have two choices. Either I will not take it. If I don't take it, do you guys agree that I go to DP I plus 1 and I still am in search of the same character? Let's say I in NAREK, I wanted to search R. If I don't pick it, I still want to search R in the next string. Yes or no? It would not magically become N, correct? Tell me, guys. Okay. Now, just think of it as a recursive problem, Ritesh. Then I'll explain why DP here. Okay. Okay. Is this much clear? Like what choice we have? Like if I don't get, right? Now, if this much is clear, if I do pick it up, all right, let's say my string is KNARRE, all right. I wanted to start from index 2, which is R. Okay. I will iterate from iterate through this string. I go to K. Do you agree? K is one of these characters, but not R, correct? That is why I would subtract my answer by 1 because GPT would subtract my answer. Now I would go to n. N is still not the index I'm looking for, but is still between n, a, r, e, k. So I would subtract it by 1. Similarly for a, I would subtract it by 1. Now, do you agree that this is r and I wanted to find r? So in this case, I would increase my answer by 1 and I would shift this pointer one step ahead, that is towards a. Now, I would go to the next index. Since it is not e, I would subtract by 1 and it's one of NAREK. And now I go to e. You can see that since this is e, I would add 1 to my answer. So this is -1 3 4 times and +1 2 times. So you can see that my answer here is, for this temporary string, it is 2 minus 4, correct? Now, this is 2 minus 4 and I have chosen this string, all right? So 2 minus 4 got added to my answer. Now, do you agree that I would go now to dp I plus 1, and since now I have found e as well, the next character I want to find is k. So do you agree I would pass dp of I plus 1 comma 4? Correct? So this is all that you have to do. And do you agree when you reach I is equal to n, I can just return, what can we return, guys? We just saw in the end, if I am left with a certain prefix, I return 2 times that index. Yes or no? We just saw that in the end, if I am left with some particular prefix, all right, here, let's say if it is NAREK, NARE. So you can see that I am on index 4 and basically I am on index 4. I need to find k. So I can return 2 times j, minus 2 times j. Yes or no? Because these characters become redundant. Yes or no, guys? Tell me. In the end, I know how many characters I have not used. So I'll just return minus 2 times j. So when I is equal to n, I just return minus 2j. All right. If this much is clear, now to tell you all why this is dynamic programming, do you agree that I have choices? It's not necessary that I would greedily pick up the strings. I need to pick up a subsequence. And because I have choices, it might be that for some other choice, all right, let's say I am at index 5 and I want to start from n, which is 0. There can be multiple possible steps that led me to 5, 0. That is why we apply dynamic programming. So let me just share the code as well. Is this much clear, first of all, guys? For don't pick, we go to I plus 1j. For pick, we find the answer and then we go to I plus 1, whatever the index is. Now tell me, guys, if this returned x and this returned y, what would be the value of dp I, j? Max x, y. Exactly. Amazing. Nice to see you all able to come up with the solution. So that is more or less it. And if I show you the code, that is exactly what I have implemented. So if you look at this, guys, I have dp of n, 5, and here I have my string, which is Narik. If index is equal to n, I return 2 times letter. Here is my dp state, where dp index letter is not equal to -1, I return dp of index letter. Apart from this, I have 2 things, take and not take. For not take, I just do f of index plus 1 and letter. All right, this is just a lambda function. That is why I'm passing self. You can just ignore this. Otherwise, for take, I have my index set, which is equal to letter, and take is 0. If I'm iterating through all characters of that particular string, I've stored it here. All right. If I is equal to s of idx, then idx is equal to idx plus 1 modulo 5, because I'm going one index ahead, and then I'm doing take plus because my score increases by 1. Otherwise, if it is not the character that we want, but it is one of NAREK, Then I do take minus minus. And then in the end, I just do take plus equal to f of index plus 1, comma idx. Yes or no, guys? Because in the end, I will have the index which I want to find next. So I go to the next index using that particular index and I add it to my take. And then dp index letter is just max of take comma not take. Is this much clear? So talking about time complexity, can you see that we are iterating over each string of size m over here? And the number of states is n into 5. So the total number of operations we are doing is n into m into 5. So the time complexity of this is big O of n into m. Okay, Shan? 5 mn, or since we remove that 5, the time complexity is big O of n into m. Is this much clear for everyone? Great. So if this much is indeed clear for everyone, let's move on to the next problem, E1, which is again dynamic programming. Let me just make a submit and see if my code actually passes. If it passes, then only we'll be discussing this. Otherwise, we won't be discussing this, right? So yeah, let me just make a submit and see if the code works. All right. Yeah, I think it's going to pass. So this is a bit of game theory, and I would like to show you all why and how to think game theory and dynamic programming today. It was a very simple question as such in terms of game theory, but since it was E1, didn't get time during the contest to read E1, wise I've solved it earlier. So let this run, and then we can go through the solution.
Gaurish,
Yes.
is this the norm that like only three portions can be done if you don't know DP and like always the fourth portion is like DP and after?
It's not necessary, but quite a lot of times the fourth question is on DP or graphs or segment trees or heavy, like some sort of combinatrix or something like that. So if you want to solve div2D topics like graphs, segment trees, dynamic programming, trees, DP on trees, all these problems, all these topics will help you. Okay. Now, guys, we have a game theory problem today. And what is this problem? Sovak and Narik are playing a game. They have an array A and matrix B of integers n rows and m columns. All right. They are looking for the elements of A in turns. Sovak starts first. Each time a player looks for a cell in the matrix containing element of A, right? Basically the frontmost element. And once they find it, they remove it. Let's say the player chose cell R, C. The next player has to choose his cell in between submatrix R plus 1 and ending n, m. All right. Now, if a player cannot find such a cell or the array ends, then that person loses. So let me just share what the problem says, guys. You are given a matrix of size n into m, and two players are playing a game. You're also given an array. Let's say the array is 1, 2, 3, 4. All right. So let's consider it terms of Alice and Bob. So Alice picks one of the cells such that the value in the cell is equal to the front element. Then Alice removes it. After this, Bob has to now select a cell from this particular subgrid such that it is equal to 2. Let's say Bob picked up this element. Now Alice has to take up from this particular subgrid for 3. So if this is 3, then it is fine. If it is not, then you can see that Alice cannot pick up anything from this subgrid. So Alice loses. So the first person who cannot make a move loses. And for example, if this was 1, this was 2, this was 3, this was 4, now you can see that it is Alice's move and there are no elements to pick up. All right, so that is why Alice loses. So the question says that find the player who wins. If both play optimally, find who wins. All right, guys, is the problem statement clear? We are given a grid, we are given an array, all right? Alice picks up a cell that is equal to that element and then removes it. Now Bob has to pick up from this subgrid and so on and so forth. Now guys, let's first solve it for an array. All right. If we are able to solve it for an array, I will show you how we can apply dynamic programming over it. The array problem is as follows. You are given an array of size n and then you are given an array of size m. This is the array where you choose from. This is 1, 2, 3, 4, 5. So Alice first chooses from chooses an element that is equal to let's say 1. After that, Bob has to choose from right hand side. Okay, guys, is this much clear? Okay, let's solve a simpler problem first. Now, consider the array is 1, 1, 2, 3, 1, 4, 5. All right. Do you agree that Alice has 3 choices for the first element? Yes or no? Correct? Now, similarly, Bob has some choices and so on and so forth. All right. Let's consider this for now. Now, guys, in game theory, let me teach you something. Each index can be said to be winning or losing. All right. And let's see how we can apply dynamic programming over it. Okay. Guys, now tell me, if I were to have this in element 5, okay, I wanted to pick this. And I picked, whoever was playing, picked up this element. All right. Do you see the next player won't be able to play? Yes or no? Like if I picked this, the next player would have to choose from here and that player loses. So that is why I say that this is a winning state, because if someone comes over here and was to pick 5, all right. So this is not exactly a winning state. If 5 was to be picked, it would have been a winning state. All right. Now consider that someone is over here and they want to pick up 4. All right. Basically, which elements I am just going through, since everything is unique, I'm just showing you that for 1, if 1 had to be picked, for 2, if 2 had to be picked, if for 3, 3 had to be picked, if would it have been winning or losing? All right. Now, guys, if someone had to pick up 4, okay, do you agree if they picked up this 4, the opponent would pick up this 5? And since this 5 is winning, this person would lose. Yes or no, guys? Basically, for this 4, the opponent would pick up this 5 because the next element to be picked is 5. And you can see that this is a winning state. So can we say the person who will pick up this 4 would lose? Yes or no? Tell me, guys. Yes. Okay. Now, similarly, let's say for this one, since everything is unique, I'm just assuming that this is the element that we are going to pick first. If someone is over here, all right, and the last index is also losing, let's just consider that for now. All right. Now, for this one, if someone picks this up, do you agree that since there are no 2s ahead, all right, this one becomes winning because there are no 2s ahead. So if someone picks up this one, they win. Correct? Now, similarly, let's look at 3. If someone picks up 3, then their opponent would have to pick up this 4. There are no choices. All right. Now, since they have to pick up this particular 4 and this 4 is losing, can I say picking up this 3 is indeed winning? Yes? Tell me, guys. Now, Similarly, for 2, if someone picked up this 2, you can see that if I picked up 2, my opponent would have to pick up this 3. There is no choice. Since this is winning, they would obviously pick this up. And then this here would be a losing state. Yes or no? Correct, guys? Yes? Okay. Now, for this particular one, if you pick this up, all right, you can notice that if I pick up this one, then my opponent is forced to pick up this 2. And since this 2 is a losing state, this is a winning state. And similarly for this one, since I would be starting here, if I pick up this one, my opponent would have to pick up this 2. And this would, since this is a losing state, this is a winning state. Is this much clear for you all guys? How I'm trying to build up winning states and losing states? Okay. Now, let me tell you all one thing very clearly how we are coming up with this. Let's say I make a choice. And for that choice, my opponent has some choices. All right. And all those choices are losing states. All right. I have a choice. And for all those choices, my opponent loses. So can I say I win in that particular state? But if in a current state, my opponent had some choices, and let's say even one of those choices won for my particular opponent, do you agree that my opponent would pick up this winning state and then I would lose? Yes or no, guys? Tell me. Yes? Okay. Now, if this much is indeed clear, can I say that for all the choices, if I bitwise OR them, if I OR all the choices of my opponent, let's say this is some variable X, can I say my winning state is nothing but not X? If OR is false, then it would be a winning state. So if everything is false or everything is losing, then it would be winning. Otherwise, if any one of these is winning, then this state would be losing. Yes or no? Yes? Okay. So guys, now we are going to bring up our DP solution. All right. DP I, J, K represents that I need to search for the kth element in my array, okay, in the subgrid I, j to n-1, m-1. Okay, guys, this is what my DP state represents. I have to search for the kth element in my subgrid I, j to n-1, m-1. Now, either this value would be 1 or 0. It would be 1 if it is a winning state, or it would be false if it is a losing state. Yes or no? Tell me, guys. Yes? Okay. Now, if this much is clear, for DP I, j, k, I have two choices. Either to pick up the ijth element or to not pick it up. Do you guys agree to pick it up? The condition that should satisfy is Gij is equal to ARR of K. Yes or no? Only then I can pick it up. Yes. Now, if I do pick it up, do you agree I would be going to, my opponent would have to choose from I plus 1, j plus 1, which is the next subgrid, and the element they would have to choose is k plus 1 as well. Yes or no, guys? Tell me. Yes. Basically, my opponent will have to choose from this. All right. And only if this is false or zero, I can say that this is a winning state. All right. Only if this is false, I will say that this is winning. This choice is winning. Otherwise, if this is one, I will say that this choice is a losing state. All right. Basically, not of dp I plus 1 j plus 1 is going to be my value. Now, if I don't pick it up, okay, if I don't pick it up, do you agree that I have to search for the kth element in my subgrid I comma j to n minus 1 m minus 1? Yes or no? Yes. If I didn't pick it up, I want to search for this element in that subgrid, right? So what do? You might be like, we can run a for loop. But guys, this is not required. How can I traverse in my entire subgrid, guys? Very easily, tell me. This is a very standard DP technique. Do you agree that currently I can just make the choice to move my I one step ahead or moving my J one step ahead? Yes or no? By doing this, can you see, if you look at it recursively, if I am at I comma j, which is here, if I move down or right, and then I recursively do this, do you agree that I would be able to visit all the cells in this subgrid? Yes or no? I can either visit I plus 1j or I comma j plus 1, correct? Tell me, guys. If we are at ij and I call I plus 1j or I comma j plus 1, right? Recursively, it visits all the cells in the subgrid, correct? Tell me, Shan. Yes. Now, if this much is clear, do you agree? This still represents that this is Alice's turn, or whoever is playing, it's that person's turn. So if any of this gives me 1, can I say that this state is winning? Because when I am going to these states, it is still Alice's turn. But when I'm going to this state, it is not Alice's turn. So I can say that dp of ijk is equal to the bitwise OR of all these three elements, not of dp I plus 1 j plus 1 k plus 1 and dp I plus 1 jk and dp I comma j plus 1 k. Is this clear, guys? Because when I'm going to the subgrid exploring the kth element, it is still that person's chance. But when I picked up the current element, it is not that person's chance. So dp I plus 1 j plus 1 k plus 1 represents the state for the opponent's move. And only if this is false or if this is losing, then I can say that it is a losing state. So the dp solution is an O of n cube solution. Let me just show this to y'all. So I take in ARR, I take in my array, and then I have my dp of n comma m comma l or dp ijk. All right. Now, if I is equal to n or j is equal to m or k is equal to l, basically if we reached outside the array or if my array gets completed, then I return 0 because this is losing. If the array gets depleted, it is losing. Or if I reach outside the state, outside the grid, it is losing. Otherwise, if dp ijk is not equal to -1, then return dp ijk. Otherwise, not take option is just bitwise or max. It doesn't matter since these values are only zeros and ones. I can take up max. If you take up or, I think that would be more intuitive. So dp ijk is just f of I plus 1 jk or f of I comma j plus 1 k. All right. And if I take this, it should only be true when gij is equal to ARR k. So instead of writing a if statement, I wrote this. If this is not true, then this would be false. Otherwise, this would return 1 and then it would get this value. All right. Now, it would be not of f of I plus 1, j plus 1 and k plus 1. Now, what is dpijk? It is bitwise OR of take or not take. Basically, if any of this is winning, then I can say this is winning. Like if this is losing, not of losing would be winning. So if any of these choices makes this a winning state, I will store this as 1. Otherwise, I will store it as 0. In the end, I call f of 0, 0, 0. If it returns me true, I will say that the first player wins. Otherwise, I say that the second player wins. Is this much clear, guys? A very simple game theory based dynamic programming solution that helped us see that how we could use dynamic programming to solve game theory problems. Is the concept of winning states, losing states, and then how we use dynamic programming to solve this clear for everyone, guys? Great. Shan says you did so that if it couldn't take, yes, Shan. I did this equal to because if this is not true, this would be 0. So this would automatically become false. It's same as a if statement. All right. I just avoided the if statement by writing this. I was in a hurry, so that is why I wrote this. But clean code practice would be just writing a if statement. If Gij is equal to ARRK, then take is equal to this. Otherwise, take is equal to false. So that is more or less it. All right. That's more or less it for this contest. We solved problems A, B1, B2, C, and E1. D was hard, and E2, I think, is the same problem with more higher constraints, which would either need DP optimization or some other observation. So you can look at the editorial for E2 if you're interested. And thanks a lot for joining in. That's it by Gaurish today. Do subscribe to our channel. See you guys next time. Bye bye.